Hi friends, the main application of calculus is to find maximum or minimum value of a function in given constraints. So we'll write here our applications, maxima and minima. The statement of these questions are usually short and the students feel that every question uses different approach. But here I will break down this problem for you. You should know that derivative at any point is the slope of tangent there, and also that the slope at extremas are 0. Okay. So it's evident from the graph, we can see here that the slope at the extreme points are 0. Let's take a question now. The question is, a right circular cone of the largest volume that can be enclosed by a sphere of 1 meter radius has height. So let's decode this question first. Okay, so what's given here? They want to maximize volume of right circular cone. So our function will be volume of the cone, which is 1 by 3 pi r square h, as you know already. Now notice V depends on two variables, r the radius of base and h height. And secondly, so height is asked, so we'll make V function of h only. And we'll find the relation between r and h. So I'm turning the page now. Now let's visualize. Okay, here is a sphere where we have to inscribe cone with largest volume. So notice that the center of sphere here lies on the axis of the cone. Thus we can say that this is a right circular cone because it's making a perpendicular from the base. Now similarly, we take another cone. See here also it coincides. The center of the sphere coincides with the axis. But in the case of this cone, it does not have its axis through the center of the sphere, so we cannot say that this is right circular cone. So now we get the idea that the axis must pass through the center of the sphere. So now let's draw the figure. We will take a sphere. Now we'll inscribe a cone which is right circular. Okay, this is the center of the sphere, and axis of the cone makes 90 degrees with the base. This is height h of cone. Radius of sphere is 1 meter. So this will become h minus 1, and r is the radius of the base of cone. Now I'll try to mark this triangle OAB and we'll apply Pythagoras theorem here. So as you can see, r square plus h minus 1 square is equal to 1 square. So r square plus h square plus 1 minus 2h is equal to 1. We expand this and we'll find the value of r in terms of h. We got the relation between the two variables now. So now we'll put this value of r square in the equation of volume so that we can find volume in terms of H. Okay, so we'll write. So we got our equation. So V is equal to Fh. Notice we found volume solely in terms of H in given constraints. Now we will find the derivative. As we already know that the slope at extremas will be 0, so we will calculate the derivative of the function. Now apply formula. Simple derivation. Now we will take this f dash h and make it equal to 0 because we know that it will give us the critical points. So now pi h bracket 4 by 3 minus h is equal to 0. So h will be either be 0 or 4 by 3. So we get two solutions here. We'll discard h is equal to 0 because there is no height, so no cone. So we are left with 4 by 3 meters. So we will check and verify that if this is maxima or not. So for that, we will take double derivative of f dash h because we know what the condition is. The double derivative should be less than 0 for a maximum point. So when you are wondering why we are doing this, because when we go near maxima, the slope starts decreasing. That's why f double dash h is less than 0. So we'll put the value 4 by 3 and we found that it's less than 0. So it's verified that this is maxima. Hence, the largest volume cone inscribed in 1 meter radius sphere has height of 4 by 3 meters. We found it. So you should just figure out two things while solving these kind of equations or questions. First of all, you should remember what's the so don't get intimidated. What's the function and what's the relation between variables. So have fun solving. Thank you.